Welcome back to section 7, Laws of Logarithms. In this video we're going to look at how we can solve questions 4 and questions 5. Now these two questions, they link onwards into the next learning intention where we're solving logarithmic equations. So you may want to save these two examples till after you do the next section, or if you wish, you're always welcome to fill in the rest of this section of the booklet now. So jumping into 4a, notice that we've got log base 10 of x squared minus 2x plus 8, and it's equal to 2 log base 10 of x. And it wants us to simplify and then solve for x. So what you'll notice about this particular logarithm is it's log base 10. So I can rewrite it without the 10 in there, or the 10 in here, and the 10 here, but I'll put it in there just for now in red because it will help illustrate what I'm going to do in just a second. So what I'm going to do is I'm going to do 2 steps before I can get rid of all of the logarithms together. So the first step I'm going to do is I'm going to use logarithm rule number 6, and I'm going to take this 2 here and I'm going to move it back inside the logarithm. And the reason for that is it's going to enable me to do the second step, which is I'm going to raise both sides of this equation to the power of 10 so I can get rid of this log base 10. So let's go ahead and do that. Alright, so now what I'm going to do is I'm going to raise both sides of the equation to the power of 10. So I'll write it as, actually I'll go to a new line and I'll write it like this. 10 to the power of log 10 blah 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 equals 10 to the power of log 10 x squared. Now because I've raised both sides to the power of 10, the 10 and the log 10, they're going to cancel like so. And what that leaves us is with a simple quadratic equation of x squared minus 2x plus 8 equals x squared. And what's really convenient is it's not actually a quadratic equation because we can cancel out the x squareds on both sides of this equation. So taking x squareds from both sides, what we're left with is minus 2x plus 8 equals 0. And then rearranging and solving for x. Therefore, we find that x is equal to 4. And to verify this solution, we look at these terms in this expression here, and we say that we need to get, say, log base 10 of x squared equal to log base 10 of x squared on the right hand side. So if we substitute in 4 into this x here, we get minus 2 times 4 plus 8, and this part in here equals 0 when x is equal to 4. So this would be the solution to this particular problem. Now going down to 4b, we're dealing with log base 10 20x minus log base 10x minus 8 equals 2. And it's asking us to solve for x again. So similar to what we did in part A, we're going to apply the same logic in part B. So the first thing I'm going to do is I'll rewrite it out. Now, one thing to pay attention to here is notice that in part A, we only had a single term expression on the left-hand side and a single term expression on the right-hand side. So when we raise both sides of the equation to the power of 10, it comes out nicely that there's a single expression on the left and a single expression on the right. Now we could do it in this example here in part B, but we have to be careful when we do that, in that when we're raising both sides of the equation, we're going to be raising it like such. So in here is going to be in parentheses. And what that will mean is that when we'd have to use our index laws to break it up even further, or otherwise we might get an erroneous, or otherwise we might get something that looks like, say, 20x minus x, or 8, not quite, x minus 8, and we know that that's not going to be correct. So the best thing, in my opinion, to do is I like to write everything as a single term expression on both sides of the equation, and the way in which we can do that is I'm going to use my logarithm law number 5 to rewrite the 20x divided by x minus 8 because of this negative there. So doing that, I'm going to write log. Okay, so now everything's in the form of log 10, and what I'm going to do is I'm going to raise everything or both sides of this equation to the power of 10. So doing that, we're going to get this situation here where it will become 20x divided by x minus 8 equals 10 to the power of 2. Alright, so now rearranging to solve for x. Rearranging for x, I find that x is in fact equal to 10, like so. So x is 10 in this instance, and if we wanted to verify that, we could simply substitute 10 wherever we see x on the left hand side of this equation, and what we'd find is that the left hand side would in fact equal 10 or 2 as well, which is in agreement to the right hand side. So that is how we do question 4. Now going down to question 5, we're posed with something that once again looks rather bamboozling, but in actuality is not that difficult or anything. It's not very different to what we've already done, but rather it's just more of it. So looking at this question, we've got log base a of 11 over 3 plus log base a of 490 over 297 minus 2 times log a. Log base a of 7 over 9 is all equal to log base a of k, and we want to find, or we want to solve for k. So we're going to use the same steps that we employed in 4a and 4b, in that firstly we're going to rewrite all of this left hand side as a single term expression. Then we're going to raise both sides of the equation to the power of a, which will cancel out the log base of a, and then we'll simply solve the equation for k. So jumping into it. So one thing to be careful of is notice this 2 here. I'm going to bring it back inside the logarithm, so it becomes 7 squared and 9 squared like so. Now rewriting everything as a single term expression on the left hand side, I'm going to use logarithm laws 4 and 5. And then we're going to raise both sides of the equation to the power of a. Alright, now what this effect will occur is that the a to the power of log a will cancel, like so. So then we're left with flipping everything around and evaluating the left-hand side expression. We find that k is equal to 10. Nice and simple. So that concludes the examples for section 7. In the next videos, we'll have a look at tackling section 8.